Algebra 1, Lesson 91. Are you ready? Here we go. We're going to talk a little bit about inequalities, and I'm going to teach you a very important trick monkey wrench that you have to be careful about. If we have an equation, let's just make it, it's not even have any variables in it. Let's say that for whatever, okay, 5 equals 2 plus 3, yeah, that sounds right. If we multiply every one of these numbers, every term, by a negative number, the equation will still be true. Let's just multiply everything by minus 2. Okay, I don't know why we would want to do that, but let's just say we wanted to. Negative 10 equals negative 4 plus negative 6. Is that still true? Yes, that is still true. So with an equation, we can multiply by negative numbers and everything is still absolutely fine. Okay, so this is with an equation. This is when we multiply an equation multiplied by a negative number. Okay, so that's what we did here. Now, the important word is equation. Now let's take an inequality. 8 is greater than 5. That's equal simple. This is an inequality multiplied by a negative. Okay, so we're going to do the same thing. We're going to multiply both sides. And let's see if it's still true, right? We're just saying that it's greater than. 8 times negative 2 is negative 16, is greater than negative 10. Is that true? No, that is not true. Here's a number line just to help you visualize it. Negative 10 is on the greater side. Negative 16 is more steps down in the hole if you want to switch metaphors and jump on my ladder in the meadow, right? 16 is further down in the hole, 10 is further up. This is false. So the moral of the story is that when we have inequalities, we cannot multiply or divide by a negative number unless we flip the sign. So here's the rule. When multiplying or dividing an inequality, when we're multiplying or dividing an inequality by a negative, we have to flip the sign. Let's do an example so we know exactly what we're talking about. 91.1. Graph the solution. Minus x greater than or equal to 2. Domain equals them reals. Arrows and either circles or dots. Okay. Well, we need to clean this up before we can graph it, and the problem I see is there's a negative number there. I don't like it. So what I'm going to do, instead of multiplying, this time I'm going to divide. True. We're going to divide that by -1. So we have to divide this by -1. And our new rule tells us we have to flip that. That's my symbol for flipping. All right, John doesn't use it. I made it up. This cancels to just plain x. This flips. Now remember, we're not talking about the trichotomy axiom here. We're not talking about negating this. We're talking about just picking it up and turning it over. So if it's got an equals component, that comes along for the right. If it doesn't, we don't add it. We're simply picking it up and changing sides. This becomes -2. Now we have a graphable inequality. X is less than or equal to -2, so we'll make this -2. Color that in because that it has equals, and we'll go that away. That's our solution. Yay. Okay, let's do another one. Graph the solution to this one. 4 minus x less than or equal to 6. This time domain is the integer, so we're dealing with polka dots. Okay, we have to clean this up. The first thing we need to do is subtract the 4. Notice that adding a negative number or subtracting, which is two ways of saying the same things, adding and subtracting doesn't flip the sign. It's only multiplying and dividing. So here we're subtracting a minus 4. That's fine. We don't have to do anything. Minus x is less than or equal to 2. That stays exactly the same. Now we have this minus sign. Last time we divided by negative 1. That's usually my go-to, but let's just multiply both sides by minus 1 this time. This is going to have to flip. So this now will become positive x. That goes the other way, and that becomes negative 2. X is greater than negative 2 or equal to. It's integers, so I'm going to go negative 3, negative 2, negative 1, 0. It includes this. So that is going to be my answer for that one, and it's correct. One more? Oh, one more in this part, then we have another part. Of course. Example 91.3, graph the solution, minus 3x plus 4, less than or equal to 13, domain equals the reals. Okay, what have we got going on here? Well, here's a best friend and here's that poor third kid. Let's send him home first. Minus 3x less than or equal to 9. Again, subtracting is fine. It's only multiplying and dividing that cause us to flip. And now we're going to have to divide by minus 3. That's going to flip. I'm going to write my answer here, and then I'll make my line over here. This now is x. This has to go the other way. Again, we just pick it up and turn it over. We don't have to rethink the equal sign at all. And then 9 divided by minus 3 would be minus 3. Domain equals the reals. Minus 3 is included in our solution, and it goes that way. Yay! I want to draw boxes. Oh, I put it right through the number. Oh well. Okay, so that's the rule on multiplying or dividing by a negative number with inequalities. You can do it, you just have to flip the sign. Okay? All right, now we're going to talk about one of my least favorite lessons. I'll be honest with you. I don't know why. This just annoys me. Spheres. We're going to find the volume of a sphere. And then we're going to talk about the surface area. They just have, it's not hard. You can get into theoretical ramifications of why it is the way it is. But I'm just going to tell you the formula. To find the volume of a sphere, please write this down in your notebook, your covers. You take 4/3 and you multiply it by pi times the radius of the sphere cubed. Oh, that is so annoying, isn't it? That's just annoying. The surface area of a sphere has a different formula that looks similar enough to be confusing, but you can figure it out. Okay? Volume has 3 dimensions. The 3 here matches the 3 under there. I'm giving you a weird, maybe that will help, maybe it won't, kind of face. You can't see me. Surface area is an area, so that's only squared. There's no 2 underneath. I mean, I don't know if that helps you, but the 3 and the 3 go together. All right? So these are our 2 fabulous formulas. We use them just the way we use any other formula. Let's do the problems. Example 91.4. John draws a bunch of pictures and diagrams in here to try to help make sense of this. I don't know if it helps or not. We don't need to draw pictures. There aren't pictures in the problems. I'm going to skip over those now because I don't want to confuse you. Find the volume of a sphere whose radius is 3 centimeters. Okay, and we need to find volume. So we're going to use this. So we do 4/3 times pi, I'll write it out as 3.14, times the radius cubed. Okay, what is 3? We'll just write it first. 3 cubed, right? So there it is. There's this formula with our radius plugged in. All right. Okay, so what I'm going to do first, I was just thinking of how I wanted to reduce this. Just to help, this is 3 to the third power is 27, right? 3 times 3 is 9, plus 3 more is 27, okay? Now, I can cancel this 3 against that 27, and it'll just be 9, right? So, that tells me, now I'm going to multiply the 9 times the 4 and get 36. The denominator's gone, and I'm just multiplying it by 3.14. You could multiply that out by hand, it wouldn't hurt a bit, and you would get 113.04 as the volume of our sphere. Just fill those in. Unit, it says centimeters, and so we know it's a 3-dimensional object, so that is our answer. Okay? If you can remember the formula, the rest of it is easy. It's remembering the formula that I don't want to say I struggle, I just find them very annoying, weird looking formulas. Okay, ready? We're going to do one with surface area. 4 pi r squared. Surface area equals 4 pi r squared. There. Now we've got it right where we need it. Find the surface area of a sphere whose radius is 4 meters. Radius equals 4 meters. Okay, again, we don't have to draw any pictures or try to make sense of this any other way. We just plug it in. Surface area equals 4 times pi, which is 3.14, times 4 squared. Okay, cool. Now we just have to simplify this. Well, I can see this is 4 times 4 squared. This would be 16. So this is actually 4 cubed, isn't it? 16 times 4. And so there's the first step in the calculation, and then you can do this by hand. You don't need to use calculators with these. I know it would be faster, but one of my former students used to always talk about how if he used the calculator too much, it made him feel like he feels when he stops working out. He feels like a fat kid on a couch. So we would always talk about how we do calculations like this so that you don't become the fat kid on the couch, right? You do them by hand so that your brain stays sharp, and it's just like working out your body. You don't want to be a fat kid on a couch. And Lydia, the tie-in for you is that the student of mine who coined the fat kid on the couch concept is Kyler McIntosh, who plays with Gabe on the Northwest University soccer team. Macintosh. Oh, he was my student for many years. We had quite a wild ride together, and I never call him Kyler, I always call him Professor. Like literally in my phone, he comes up as Professor. So he coined this term, fat kid on the couch. Don't be a fat kid on the couch. Multiply that out, and you will get an answer of 200.96. And you'll go, I don't remember, what units are we even talking about? It's surface area, so it's 2-dimensional. The unit is meters squared. That's the right answer. Yay! So now you know how to calculate the volume and the surface area of spheres. Honestly, you guys, I hate to say it, but it's worth memorizing those formulas because they show up on tests. And it's a great way to kind of boost your performance a little bit and be smarter. Oh my gosh, I just realized I'm not talking to and Jayla. I'm talking to my algebra students. So this is still relevant to you. Kyler McIntosh plays on the NU team with Gabe. I said that, so it makes sense. I'm sorry, I got crazy and thought I was talking to my algebra 2 students, but this is algebra 1. Abby, Kyle, Micah, Bradley, Cooper. How could I forget? I'm so sorry. But anyway, don't be a fat kid on the couch, multiply it through. All right, that's lesson 91. I am done torturing you with that now. Goodbye.